Ciao a tutti. Okay. My name's Italian, right? Because my grand family come from Ischia in Napoli Bay, but I don't speak even a word of Italian. So this talk will be in English, but in French English. So probably you will be able to understand. I'm working at Elasticsearch for more than 1 year now. So basically, don't trust me. Okay, all what I'm going to say is bullshit. Just try it yourself later. As you can see, you have a hashtag here, Elasticsearch. Please do some tweets with that hashtag because my income is based on the number of tweets I get. So please take picture, whatever you want, and tweet. Who knows that? Who knows that? I have some trouble with the mic. Okay. Who knows that? Sorry. Yes. ZX81. If you know that, you are probably as old as I am. So I'm 42 years old. And actually, that was my first computer. I was maybe 7 or 8 years old when I started to code with that. And if you remember it, there was 1 kilobyte of memory inside. My father upgraded this thing to 16 kilobytes of memory, and that was big data. So today we are going to talk about data and how we can make sense of our data. What is the data actually? This is a text message on a mobile phone. So you have unstructured data here, the text, but maybe you have associated with that some structured data such as the caller ID, the date, something along those lines. This is data. A tweet is data. You have a lot of unstructured data as well, but if you look at the tweet in the JSON API, you can see that you have many fields and structured fields associated with a tweet. So you have a date, you have the user who did the tweet, actually, here Codemotion, number of retweets. This is not a big number of retweets. I hope that you will make more tweets than that, and some other stuff. If you look at Deezer, I think you know Deezer in Italy, right? So Deezer basically use Elasticsearch as a backend system. So if you are developing around Deezer API, behind the scene you are using Elasticsearch. So if you look at a track on Deezer, this is not only a title and a duration, but many other information you can have here. So your data looks like this. This is data. This is logs. Okay, actually, for us, logs are more like this. So here, it's probably Apache logs. You have a date, the method, a URL, maybe the status code here, and that kind of stuff later. And every day we generate a lot of those data. Books are also data. In a book, you can find a big section of text, but probably you have also some metadata associated with the book, such as the title, the author, publisher, the date, maybe the price, whatever. So all those are data. When it becomes big? Actually, it becomes big when it becomes to crash Excel. And seriously, how many data you can how many data you can put in your Excel spreadsheet? 65,000 maybe, but I'm sure you can put into Excel 1 million of data, right? Remember those days? In 2005, micro SD card was managing 128 megabytes, and now we have on the same surface 128 gigabytes. All is still increasing. I find this picture really interesting. This year, we are going probably to produce on the Earth around 8 zettabytes of data. And in the future, in the next 5 years, we will produce 35 zettabytes of data. Actually, what is a 35 zettabytes of data? This is that number. I can't even pronounce that number. This is really big, really big. I'm sorry for the mic. It's really... Oh, okay. Storage is not really a concern. You have plenty of tools to store your data. But to me, the main concern is the velocity of the data. Data are moving very fast. So each minute, we produce many data. I'm sorry for that. Yeah, maybe I should use the other mic or, yeah. This is the backup. Okay. I love wire. Okay. Thank you. So, yes, data are moving really fast, and people don't want to have to wait for hours to compute and analyze their data. They want to be able to do that in real time, and they want to be able to react in real time. And actually, this is the most challenge I think now we have to face. And we can search for data. This is a picture of my son, Max. I found this picture really interesting because he's searching for something and there are logs here. So I find this picture really useful. And to me, search, before I knew search engine, was SQL search. And SQL search is something like this. When you are searching for something in a SQL database, basically you are doing some search, some join between tables. This is not a problem. You are searching for date. This is not an issue. And here, I feel like that we are going to have some trouble here. Okay, it works very fine when you have 100,000 documents maybe in your data store. But what happens when you scale up to 1 million documents or 1 billion documents? Can you inject and search at the same time with your SQL database? This is really a challenge. So maybe we could think about search. Actually, why do we use a data store for searching? A data store is for storage for me. Okay? Why not using a search engine? Because a search engine is designed for that purpose. What is a search engine, actually? A search engine builds index. For example, in an index, you associate terms with the object ID where you find the term. So, for example, I have indexed pages here. So, if I look at breakdrums, I know that breakdrum has been found in object 76, 77, and 102. This is basically how an object, a search engine works. So we create index, and then we search only in the index. We don't search anymore in the source data. This is really important to keep that in mind. Okay, what is Elasticsearch? Elasticsearch is built on top of Lucene, and Lucene is probably the most powerful information retrieval library you can find in the open source world. And maybe if you compare with the closed source world, it's probably the best you can have. But one of the problems you have with Lucene is that it's built on top of Java. I'm not bashing Java because we are doing Java at Elasticsearch, so Java is perfectly fine, but when you want to use Lucene with other technologies, it becomes a challenge. So Elasticsearch is exposing all the future exposed by Lucene using a REST and JSON API, and provide also some other features. So you don't have to worry about your technology stack. Another concern with Lucene is the scalability. With Lucene, you can scale up means that you can add more memory, more CPU, more disk, but at the end you will hit the roof. So what Elasticsearch is doing, Elasticsearch is providing a horizontal scalable solution around Lucene. So we are distributing your data, we shard your data, we add the replication, we add the failover, we add the load balancer, everything is built in. So you can scale out now and have an infinite number of data you can manage with Elasticsearch and Lucene. And Elasticsearch is really easy, plug and play, I wrote, because you just have 30 seconds to start. Actually, 28 seconds to download the project and 2 seconds to start. That's enough. Everything is under Apache 2 license, so really friendly for your business, so use it. Please use it. Let's imagine that you have downloaded Elasticsearch. The first thing you have to do is to start Elasticsearch. You don't have to provide anything. The only thing you have to provide is the JVM. That's all you have to install. So you download Elasticsearch, you unzip Elasticsearch, you start Elasticsearch. And that's it. And now what you can do with that, the second thing you can do, you can index documents. So it's really easy to start, as I mentioned before. In 2 seconds you can do that. So what I'm doing here, I'm putting a document in an index named sessions. The document has a type. The type name is session here. And then I provide here an ID, which is ID number 1. And this is my JSON document. Elasticsearch is going to index all that data automatically. If you want to make an analogy with the relational database, an index can be seen as a schema, type can be seen as a table, and the document itself is a table entry. Yeah. What can I do with that? I have indexed a document. I can search now. Second line, I search. What I want to do here, I want to apply the search method on my index for this type. And this is the query I want to run. So my query here is a multi-match query. I want to search those terms, Elasticsearch, Codemotion, and David. I want to search those terms in fields title, tags, and speakers.firstname, for example. This is the full text search, actually, right? And if I find what I'm looking for in the title field, I want to boost the result, because this document will have more. I'm sorry, I'm searching my term. Relevance. Thank you. Will be more relevant than the other one. So I'm boosting that field by 3. I'm boosting that field by 2, and the other one stay by 1. And then I can apply also structured filter. For example, here I want to filter my documents using a range filter on my field date, and I want to filter documents only between those 2 dates. As an answer, Elasticsearch will provide the first 10 more relevant documents in a few milliseconds, whatever the number of documents you have in your index. And Elasticsearch will provide an API which will let you navigate into the data, so you can change the size of a page and navigate from one page to the other page. Okay, this is search. But I was talking about computation, how you can compute data. And is it a good idea to use a search engine to compute some data? Actually, yes. Why this? Because if you look at this index, for example, you can see that for bucket seats, I have how many? 5 objects here. If I look at body styles, this is a big collection of pages, right? So if I want to build the top 10 values I have in my data set, I just have to look at the top 10 biggest collection on my index. And this is easy to compute. So yes, we can compute some things on an inverted index. How we do that? Using the same API. So I'm still running my search and my query as before. And now I want to compute an aggregation. I can put as many aggregation as I need. So here, what I want to compute a date histogram based on field date, and the interval I want to create for all my buckets, it's per day. If I want month, I put month. If I want year, I put year. If I want every 2 weeks, I put 2W. This is really easy. As an answer, Elasticsearch will give you the first 10 more relevant documents, and also the aggregation results. So for example here, the by date aggregation will return that number of docs for this date and the other amount, as you can see here. And with that, you can compute nice Excel-like graphics. We can do aggregation on dates, on locations, mean geopoints. You can compute aggregation on values, on terms, strings. And the cool thing is that everything is in real time. Okay? And this is one of the promises we are making with Elasticsearch. You put your data into Elasticsearch as soon as you get your data. So you stream your data into Elasticsearch. Then you search, you get your data back, and you can compute. So it means that you can explore, which means slice and dice into your data, and everything in real time. So you can make sense of your data, of any data. You can make sense of logs, of Twitter feeds, of some technical stuff like GitHub's entries, I don't know, some marketing data. You can make sense of your data, and you can make sense of your big data as well. Why I'm saying that? Because often people say, okay, I don't have 10 million of documents to manage, so I don't need Elasticsearch. But it's really easy to put Elasticsearch in your system. So please use it for small data as well. It works perfectly for small data. It works for big data, of course. I'm going to run a demo about marketing data. So I'm going to inject some documents who look like this. I have a name, I have a date of birth, I have a gender, number of children, some marketing data, which are the number of times a user click on the fashion button, for example, on the iPhone application. So center of interest, and an address like this. I'm going to inject 1 million documents like this, and I'm going to use Kibana on top of that. Kibana is a project built by the Elasticsearch team as well. It helps you to build visualization on top of your data, and it's also under Apache 2 license. So use it as you want. Okay. I'm trying to do that with one hand. Okay. Yes, you can see that. So I already started an Elasticsearch node locally on my cluster. This is what you can see here. This is my node running. On my node, I'm using here the Marvel interface. Marvel is our commercial product around Elasticsearch, which helps you to manage and understand what's going on your cluster and what happened during the night on your cluster. So we are gathering a lot of metrics around the cluster. What I want to show you here is that on the bottom, you have only one index with only one document. What I'm going to create now is a person index. So I have an empty Elasticsearch now running. There is no trick. Okay. So I built an injector in Java. Just showing this. With this injector, I'm going to inject 1 million documents in my cluster. So I'm starting to inject that. So I'm doing 10,000 per 10,000. So the first one could be maybe long. Okay, it's running. Let's see what is happening on our cluster. I'm going to change the refresh here. 5 minutes. And I want to see only the last 5 minutes. Okay, as you can see, I have an index now, which has been created. And I have the number of documents here, which is increasing. So I'm around 6,000 documents per second indexed here. So I can look at many metrics using Marvel. In Marvel, you have a nice sub-application which name is Sense. And Sense helps you to create your queries and play with your data. So for example, here I want to run on my index person a search query. The cool thing with Sense is that you have auto-completion. So now I want to run a query. And the query I want to run is match all. Match all means give me everything. Okay, run that. So as you can see, I have indexed. Can you see it? Yes? Okay. About 500,000 documents here. If I run it again, you can see that everything happened in real time. Okay. If I want to look for data, for example, I want to run a match query now, and the match query will be on country, and I'm looking for people in Italy. Okay, this is the result of my full text search. I have now 200,000 documents. Okay? Nice. Let's go back to our cluster overview. Okay. I want to see the last 5 minutes. And maybe 5 seconds. Okay, I have around, yes, it's almost done. I have injected a lot of data like this, but now I want to understand what are my data. So I'm going to switch to Kibana. So Kibana is an AngularJS application, so it runs in the browser. You don't have to install anything. I'm going to start with a blank dashboard here. So I'm opening Kibana. I start with a blank dashboard. First thing I have to do is to set my dashboard. I want to work on my index name person. Okay, done. And now I want to run a query. If I run the query, actually it runs something, but I'm not displaying anything, so okay, let's display something. I want to add a new row, and I want to display some analytics. With one hand, it's really hard. Okay, now I have rows, and in each row I can put graphical panels. So let's add a panel here. The first thing I want to do is to display the number of hits, which answers to my query. Okay, save. Okay, I have my 1 million documents here. Can I search? Yes. I'm searching for Joe. Okay, I have that number of Joe. Do I have as well some John? Okay, this is the total number of Joe and John I can have in my dataset. But what is the distribution between Joe and John? Let's change that panel and move it to a bar panel. I know that there is an issue now with Kibana, but okay. This is the total number of green and yellow. So let's modify that. I want to add a legend here. This is Joe. Put that in blue. Okay, and the number of John. Pink. Okay. You remember that I have a date of birth, so I can build date histogram, as I mentioned before. Let's do that with Kibana. I want to add an histogram panel. Let's make it bigger. And I want to apply it on date of birth field. Okay. This is the distribution of my Joe and John broken by year. Okay, I have the gender. So maybe I want to compute the distribution by gender. Let's do this. I can use a terms panel. The terms panel we'll call the terms aggregation on gender field. And the terms aggregation compute the top 10 values in my dataset. Actually, I have only 2 values here, I expect. So this, let's display it as a pie. Oh, there is something strange, right? I have 26% of females who are Joe or John. Okay, let's analyze that. I'm going to add a new row and for displaying my results. Let's make it bigger. Save. And in this row, I'm going to add a single table panel. Up, it's going to take all the space. What you can see here is the result of the JSON documents I have in my index that correspond to Joe and John. On the left, you can see all the fields Elasticsearch knows about your JSON documents. So Kibana asks Elasticsearch to list that fields. So now I can select any field I want. So let's display the name. I want the gender, date of birth, number of children, I don't know, the country, the city, cars, whatever value I want. Okay, that's it. So I have here my values. I can click on any line and see the actual content of the JSON document on a table view, with a table view, or with a JSON view as you want. So I have a concern with females. I don't have a concern myself with females. This is just for the demo, all right? Okay. So I'm going to add a filter now. I'm going to click on the terms panel here, on the female, and it will add a filter here in that section. So let's do it. Okay, so now I have filtered all my data, and I'm only displaying females. And what I can see here at the end, I don't know if you can see it, but Joe and John actually is the last name. So this is not an issue. This is correct. What I can do with that, I can store my dashboard into Elasticsearch itself. That was the reason of the first index you have at the beginning, the Kibana-int. And so I can reopen my dashboard later. So I built a dashboard before coming. So I'm interested in people having clicked more than 1,000 times on cars and on food. So this is the distribution of value. This is the distribution by gender, date of birth, the location in Europe, the cities. Here I have a geo-clustering view only on the top 1,000 top values we have in the dataset, because you cannot render 1 million documents on a browser. Not yet, but we have something in the future. We will come in Elasticsearch. And I also compute a statistics here, which is the mean of the number of the children the family have here, broken by the center of interest, so for cars and for food. So what I can do now, I can say, okay, I'm interested in females born in the 70s, like me. Okay, but in Italy. Okay, and now I want to see Rome. Okay, and this is actually the value. So I built again Mythic. And those girls are interested by cars and food, so that's perfect for me. And this is what we want you to do with Elasticsearch. You can do that on top of your data, whatever your data are. It could be logs, it could be, I don't know, declaration of goods in a custom system, for example, whatever. Okay. Let's go back to my slides. I'm not sure I was on my best profile. Okay. Okay. I have 10 minutes, I think. Thank you. Okay, in Elasticsearch, there is the name Elastic, right? So those are elastics, not spaghetti. My wife took that picture one day and she told me, darling, you can come back home because I found the elastic. So you don't have to search for elastic anymore. Okay, I said that Elasticsearch can scale, but how does it work? Actually, you can, when you create an index into Elasticsearch, it comes per default with sharding settings. So by default, when you create an index, we will shard your data into 5 shards. But you can set that. Before injecting your first document, you can say, okay, I'm going to create an index, and I want 4 shards, and I want to replicate each shard 1 time in the cluster. So if I have only 1 node starting in my cluster, Elasticsearch is going to allocate first the primary shards, like this. You can create another index. We are multi-tenancy, and this new index will have other properties. So for example, I want only 2 shards, and I don't want to replicate my data. So this time I'm going to create that. What happens when you start a new node? When you start a new node, the first thing Elasticsearch has to do is first to register itself to the other node and say, hey, we are 2 now, we can form a cluster. And then, as the node comes in, the first thing Elasticsearch has to do is to respect your replication rule. So you said that you want to replicate all the orders, all the shards in the orders index once. So Elasticsearch will allocate the orders index on node 2 and then replicate data. But also, Elasticsearch will try to have an even distribution of your shards across nodes. So, for example, here we have 6 shards here, but only 4 here. So Elasticsearch will decide to move 1 shard to the other node. And what will happen if you add a new node into the party? So it will be automatically detected. And then Elasticsearch will say, okay, I have new power now. I can use that power. So I am going to move my shard in the other node. So something like this. Yeah, that's it. Replicas serve also as backup, but also serve for queries. Actually, when you index a document, you can index your document by sending your request to whatever node you want. You don't have to think about the allocation behind the scene. Just send your index query. Elasticsearch will route your query to the right shard, the primary shard, and then replicate it to the replica shard. So when you search, you know that this shard is somehow synced with this one, so you can search primaries and replica as well. And this is very cool because if you have a huge traffic and a huge demand about the number of requests you can have on your cluster, just add the number, just increase the number of shards. You can do it live, by the way. The cost behind is the space, the disk, the disk space, yes. Elasticsearch as a company, we are building 4 tools. So I talk about Elasticsearch today and Kibana. We have also another tool, the name is Logstash. Logstash is like an ETL tool. So you extract your data from somewhere, you transform your data and you load your data to Elasticsearch. So basically it helps you to stream your data into Elasticsearch. And then we have also our commercial product now, which is Marvel, which is free for development, so you can use it also when you start with Elasticsearch. We are offering some training. I really recommend, as a developer, I'm not a sales guy, but as a developer, if you are starting a project with Elasticsearch, go to the training. Really, it's 2 days long, and it will be very useful for you. And we are providing development support and production support as well. And yes, we are selling Marvel also. Some users, I already mentioned Deezer. Actually, maybe you know Foursquare. There is 40 million of venue indexed into Elasticsearch. I'm pretty sure that you know WordPress. Wikipedia is actually moving all its stuff to Elasticsearch now. I'm pretty sure you are using GitHub every day and you are searching for code. In Elasticsearch, we have indexed billions of lines of code into Elasticsearch. So if you search for code, you can see that it's fast and pretty fast. BlaBlaCar, you know that in Italy? Yeah, I think. So they are using it and they have that in 13 countries, I think, something like this. Okay, Dailymotion. 40 million of video indexed. For Facebook, it's not the search on the Facebook page. It's for internal purpose. So they are using that now for internal purpose. Big companies like banks and insurance are also really interested in Elasticsearch, and they put Elasticsearch in place. I think I'm done. Do you have any question? Feel free to ask. Even in English, you know, my English is not really good. Okay, so yes. Maybe we need a microphone, or what is the? No? Maybe I will try to repeat the question. Okay, so the question is, can you link data? If you have users and content, can you link those data? The answer is yes, you can do that, because in Elasticsearch we have somehow a relationship model you can use, which name is the parent-child relation, but it comes with a cost. If you can build your data without the need of that, and for example, maybe by reindexing 2 times the same data, maybe that would be more efficient than using parent-child. Parent-child comes with a cost in terms of memory, because if you want to do fast lookup, join in memory, you have to do that in memory. So, but we manage that. Over? Yes.
Can you explain a bit more automatically detected? So,
thanks.
just the gossip protocol you are using.
Okay, thank you. The question is, if I can explain a little more how the discovery process works. So by default, the discovery process is using multicast. So it broadcasts and try to find nodes on your network. This is something which doesn't work in cloud environment, for example. So for that, we have plugins. And you have 2 choices, actually. You can build a unicast list of nodes and then just set that list. Or you can use plugins, and we have plugins for EC2, Amazon, for Azure and Google Compute Engine. So by plugins, we are asking the REST API of those vendors, and then we can get the list of nodes by that. Did I answer?
But if the nodes are on the same network, multicast is working.
If it's in the same network, multicast is working, yes. And this could lead to trouble, because when you start with Elasticsearch, by default, you have a cluster name. The name is Elasticsearch. So if your colleague starts as well an Elasticsearch node, then delete all the index, then your index are wiped. So you have to be careful with that. Yes?
Number of pages. I want to display a panel in Kibana where I can search for book titles and aggregate the total number of pages. I discovered, because I already tried, that if you use the not analyzed on the book title string, you can have a nice panel with
Sure.
the entire title.
Yeah.
If you don't do that, you have the single token.
Yeah.
So is it possible to have I don't know, some combination of tokens?
Yes. Maybe the question you have is, can I broke my data? For example, I want to display the number of. Let's take again my example. I have the number of person per year, and maybe per year I want to display the top 10 values of gender, how many per bucket I have, and then per gender, maybe I want to compute the mean of the children. Maybe it's your question. So it's aggregation of aggregation and of aggregation. Is it what you are looking for? Okay. So this is something we have in Elasticsearch, but it's not already ready into Kibana. For now, for Kibana, with Kibana, you have only one layer of aggregation. Yeah, it will come in the future. We are building Kibana 4, but it won't be here before the end of the year, I think. I'm done. So just grazie. Thank you, and don't trust me. Okay, try it. Thank you.